A Java applet is a small application which is written in Java and delivered to users in the form of bytecode. The user launches the Java applet from a web page, and the applet is then executed within a Java virtual machine in a process separate from the web browser itself. A Java applet can appear in a frame of the web page, a new application window, Sun's Applet Viewer, or a standalone tool for testing applets. Java applets were introduced in the first version of the Java language, which was released in 1995. Java applets can be written in any programming language that compiles to Java bytecode. They are usually written in Java, but other languages such as Python, Java, Pascal, Scala, or Eiffel may be used as well. Java applets run at very fast speeds, and until 2011, they were many times faster than JavaScript. Unlike JavaScript, Java applets had access to 3D hardware acceleration, making them well suited for non-trivial, computation-intensive visualizations. As browsers have gained support for hardware-accelerated graphics thanks to the Canvas technology, as well as just-in-time compiled JavaScript, the speed difference has become less noticeable. Since Java's bytecode is cross-platform, Java applets can be executed by browsers for many platforms, including Microsoft Windows, FreeBSD, Unix, OS X and Linux. Overview. The applets are used to provide interactive features to web applications that cannot be provided by HTML alone. They can capture mouse input and also have controls like buttons or checkboxes. In response to user actions, an applet can change the provided graphic content. This makes applets well suited for demonstration, visualization, and teaching. There are online applet collections for studying various subjects, from physics to heart physiology. An applet can also be a text area only, providing, for instance, a cross-platform command line interface to some remote system. If needed, an applet can leave the dedicated area and run as a separate window. However, applets have very little control over web page content outside the applet's dedicated area, so they are less useful for improving the site appearance in general. Applets can also play media in formats that are not natively supported by the browser. Pages coded in HTML may embed parameters within them that are passed to the applet. Because of this, the same applet may have a different appearance depending on the parameters that were passed. As applets were available before CSS and HTML were standard, they were also widely used for trivial effects such as rollover navigation buttons. Heavily criticized, this usage is now declining. Technical information. Java applets are executed in a sandbox by most web browsers, preventing them from accessing local data like the clipboard or file system. The code of the applet is downloaded from a web server, after which the browser either embeds the applet into a web page or opens a new window showing the applet's user interface. A Java applet extends the class Java applet, or in the case of a Swing applet, Javafx, Swing, Japlet. The class, which must override methods from the applet class to set up a user interface inside itself, is a descendant of panel, which is a descendant of container. As applet inherits from container, it has largely the same user interface possibilities as an ordinary Java application, including regions with user-specific visualization. The first implementations involved downloading an applet class by class. While classes are small files, there are often many of them, so applets got a reputation as slow-loading components. However, since jars were introduced, an applet is usually delivered as a single file that has a size similar to an image file. The domain from where the applet executable has been downloaded is the only domain to which the usual applet is allowed to communicate. This domain can be different from the domain where the surrounding HTML document is hosted. Java system libraries and runtimes are backwards compatible, allowing one to write code that runs both on current and on future versions of the Java virtual machine. Similar technologies. Many Java developers, blogs and the magazines are recommending that the Java Web Start technology be used in place of applets. Java Web Start allows the launching of unmodified applet code, which then runs in a separate window. A Java servlet is sometimes informally compared to be like a server-side applet, but it is different in its language, functions, and in each of the characteristics described here about applets. Embedding into a web page. The applet can be displayed on the web page by making use of the deprecated applet HTML element, or the recommended object element. The embed element can be used with Mozilla family browsers. This specifies the applet's source and location. Both object and embed tags can also download and install Java Virtual Machine, or at least lead to the plugin page. Applet and object tags also support loading of the serialized applets that start in some particular state. Tags also specify the message that shows up in place of the applet if the browser cannot run it due to any reason. However, despite object being officially a recommended tag as of 2010, the support of the object tag was not yet consistent among browsers, and some kept recommending the older applet tag for deploying in multi-browser environments, as it remained the only tag consistently supported by the most popular browsers. To support multiple browsers, the object tag currently requires JavaScript usage of additional browser-specific tags or delivering adapted output from the server side. Deprecating applet tag has been criticized. Oracle now provides a maintained JavaScript code to launch applets with cross-platform workarounds. Example. The following example illustrates the use of Java applets through the Java applet package. The example also uses classes from the Java Abstract Window Toolkit to produce the message, "Hello, World," as output. Import Java applet, import java.aut applet code for the "Hello, World" example. This should be saved in a file named as Hello World Java. Public class Hello World extends applet, print a message on the screen. Public void paint draw string draws a circle on the screen. Drawik. Simple applets are shared freely on the internet for customizing applications that support plugins. After compilation, the resulting class file can be placed on a web server and invoked within an HTML page by using unless than applet greater than or unless than object greater than tag. For example, less than doc type HTML greater than less than HTML greater than less than head greater than less than title greater than hello world underscore example.html less than title greater than less than head greater than less than body greater than less than h1 greater than a Java applet example less than h1 greater than less than p greater than here it is. Less than applet code equals hello world.class, height equals 40, width equals 200, greater than this is where hello world.class runs. Less than applet greater than less than p greater than less than body greater than less than HTML greater than when the page is accessed it will read as follows. A Java applet example, here it is. Hello, world. To minimize download time, applets can be delivered in the form of a jar file. In the case of this example, if all necessary classes are placed in the compressed archive example.jar, the following embedding code could be used instead. Less than p greater than here it is. Less than applet archive equals example.jar, code equals hello world, height equals 40, width equals 200, greater than this is where hello world.class runs. Less than applet greater than less than p greater than applet inclusion is described in detail in Sun's official page about the applet tag. Advantages. A Java applet can have any or all of the following advantages. It is simple to make it work on FreeBSD, Linux, Microsoft Windows and OS X, that is, to make it cross-platform. Applets are supported by most web browsers. The same applet can work on all installed versions of Java at the same time, rather than just the latest plugin version only. However, if an applet requires a later version of the Java runtime environment, the client will be forced to wait during the large download. Most web browsers cache applets so they will be quick to load when returning to a web page. Applets also improve with use. After a first applet is run, the JVM is already running and starts quickly. It should be noted that JRE versions 1.5 and greater stop the JVM and restart it when the browser navigates from one HTML page containing an applet to another containing an applet. It can move the work from the server to the client, making a web solution more scalable with the number of users, clients. If a standalone program talks to a web server, that server normally needs to support all prior versions for users which have not kept their client software updated. In contrast, a properly configured browser loads the latest applet version, so there is no need to support legacy versions. The applet naturally supports the changing user state, such as figure positions on the chessboard. Developers can develop and debug an applet directly simply by creating a main routine and calling an issue on the applet, thus allowing for development in their favorite Java development environment. All one has to do after that is retest the applet in the applet viewer program or a web browser to ensure it conforms to security restrictions. An untrusted applet has no access to the local machine and can only access the server it came from. This makes such an applet much safer to run than a standalone executable that it could replace. However, a signed applet can have full access to the machine it is running on if the user agrees. Java applets are fast, and can even have similar performance to native installed software. Disadvantages. A Java applet may have any of the following disadvantages compared to other client-side web technologies. Java applets depend on a Java runtime environment, which is a reasonably complex and heavyweight software package. It also normally requires a plugin for the web browser. Some organizations only allow software installed by an administrator. As a result, some users can only view applets that are important enough to justify contacting the administrator to request installation of the JRE and plugin. If an applet requires a newer JRE than available on the system, or a specific JRE, the user running it the first time will need to wait for the large JRE download to complete. Some browsers, notably mobile browsers on Apple iOS or Android, do not run Java applets at all. Unlike the older applet tag, the object tag needs workarounds to write a cross-browser HTML document. There is no standard to make the content of applets available to screen readers. Therefore, applets can harm the accessibility of a website to users with special needs. Compatibility-related lawsuits. Sun has made considerable efforts to ensure compatibility is maintained between Java versions as they evolve. Enforcing Java portability by law if required. Oracle seems to be continuing the same strategy. 1997 Sunday vs. Microsoft. The 1997 lawsuit was filed after Microsoft created a modified Java virtual machine of their own, which shipped with Internet Explorer. Microsoft added about 50 methods and 50 fields into the classes within the java.ort, java.lang, and java.io packages. Other modifications included removal of RMI capability and replacement of Java native interface from JNI to RNI, a different standard. RMI was removed because it only easily supports Java to Java communications and competes with Microsoft ECOM technology. Applets that relied on these changes or just inadvertently used them worked only within Microsoft's Java system. Sun sued for breach of trademark, as the point of Java was that there should be no proprietary extensions and that code should work everywhere. Microsoft agreed to pay Sun $20 million. And Sun agreed to grant Microsoft limited license to use Java without modifications only and for a limited time. 2002 Sunday vs. Microsoft. Microsoft continued to ship its own unmodified Java virtual machine. Over the years it became extremely outdated yet still defaults for Internet Explorer. A later study revealed that applets of this time often contain their own classes that mirror Swing and other newer features in a limited way. In 2002 Sunday filed an antitrust lawsuit, claiming that Microsoft's attempts at illegal monopolization had harmed the Java platform. Sun demanded Microsoft distribute Sun's current, binary implementation of Java technology as part of Windows. Distribute it as a recommended update for older Microsoft desktop operating systems and stop the distribution of Microsoft's virtual machine. Microsoft paid $700 million for pending antitrust issues, another $900 million for patent issues, and a $350 million royalty fee to use Sun's software in the future. 2010 Oracle vs. Google. Google has developed their own Android platform that uses Java features and concepts, yet is incompatible with standard libraries. This may be a violation of conditions under which Sun granted OpenJDK patents to use open-source Java for all. In 2010, Oracle sued Google for using Java in a wrong way, claiming that Google's Android competes with Oracle America's Java, and that Google has been aware of Sun's patent portfolio, since Google hired certain former Sun Java engineers. In May 2012, the jury in this case found that Google did not infringe on Oracle's patents, and the trial judge ruled that the structure of the Java APIs used by Google was not copyrightable. Security. There are two applet types with very different security models: signed applets and unsigned applets. As of Javafx 7 Update 21, applets and web start apps are encouraged to be signed with a trusted certificate, and warning messages appear when running unsigned applets. Further, starting with Java 7 Update 51, unsigned applets are blocked by default. They can be run by creating an exception in the Java control panel. Unsigned limits on unsigned applets are understood as draconian. They have no access to the local file system and web access limited to the applet download site. There are also many other important restrictions. For instance, they cannot access all system properties, use their own class loader, call native code, execute external commands on a local system, or redefine classes belonging to core packages included as part of a Java release. While they can run in a standalone frame, such frame contains a header, indicating that this is an untrusted applet. Successful initial call of the forbidden method does not automatically create a security hole, as an access controller checks the entire stack of the calling code to be sure the call is not coming from an improper location. As with any complex system, many security problems have been discovered and fixed since Java was first released. Some of these persisted for many years with nobody being aware. Others have been discovered in use by malware in the wild. Some studies mention applets crashing the browser or overusing CPU resources, but these are classified as nuisances and not as true security flaws. However, unsigned applets may be involved in combined attacks that exploit a combination of multiple severe configuration errors in other parts of the system. An unsigned applet can also be more dangerous to run directly on the server where it is hosted, because while codebase allows it to talk with the server, running inside it can bypass the firewall. An applet may also try DOS attacks on the server where it is hosted, but usually people who manage the website also manage the applet, making this unreasonable. Communities may solve this problem via source code review or running applets on a dedicated domain. The unsigned applet can also try to download malware hosted on originating server. However, it could only store such file into a temporary folder and has no means to complete the attack by executing it. There were attempts to use applets for spreading Phoenix and Siberia exploits this way, but these exploits do not use Java internally and were also distributed in several other ways. Signed. A signed applet contains a signature that the browser should verify through a remotely running, independent certificate authority server. Producing this signature involves specialized tools and interaction with the authority server maintainers. Once the signature is verified, and the user of the current machine also approves, a signed applet can get more rights, becoming equivalent to an ordinary standalone program. The rationale is that the author of the applet is now known and will be responsible for any deliberate damage. This approach allows applets to be used for many tasks that are otherwise not possible by client-side scripting. However, this approach requires more responsibility from the user, deciding whom he or she trusts. The related concerns include a non-responsive authority server, wrong evaluation of the signer identity when issuing certificates, and known applet publishers still doing something that the user would not approve of. Hence, signed applets that appeared from Java 1.1 may actually have more security concerns. Self-signed applets, which are applets signed by the developer themselves, may potentially pose a security risk. Java plugins provide a warning when requesting authorization for a self-signed applet, as the function and safety of the applet is guaranteed only by the developer itself, and has not been independently confirmed. Such self-signed certificates are usually only used during development prior to release, where third-party confirmation of security is unimportant. But most applet developers will seek third-party signing to ensure that users trust the applet's safety. Java security problems are not fundamentally different from similar problems of any client-side scripting platform. In particular, all issues related to signed applets also apply to Microsoft ActiveX components. As of approximately January 1, 2014, self-signed and unsigned applets are no longer accepted by the commonly available Java plugins or Java Web Start. Consequently, developers who wish to deploy Java applets have no alternative but to acquire trusted certificates from commercial sources. Alternatives. Alternative technologies exist that satisfy some of the scope of what is possible with an applet. Of these, JavaScript is not always viewed as a competing replacement. JavaScript can coexist with applets in the same page, assist in launching applets and later be called from the applet code. Javafx is an extension of the Java platform and may also be viewed as an alternative.